Hey guys, hopefully you're having a okay day. We're going to be going over properties of exponents today, but before we do that, we're going to do some critical thinking problems. Remember, these are the multiplies to be something, adds to be something. Okay, so go ahead. Okay, I want you to go ahead and pause the video, and I want you to try to get all four of these. Multiplies to be something, adds to be something. Okay, reminders. If you're unsure, okay, you always start off with 1 in the number. So 1 times 32 is 32. And then we just check the addition. 1 plus 32 is 33. That's not it. Next number is 2. 32 divided by 2 is 16. So 2 times 16 is 32. 2 plus 16 is 18. So that won't work. 32 divided by 3 is a decimal. 32 divided by 4 is 8. So 4 times 8. And we have it. It's 4 and 8. Okay, 4 and 8. Number 2, we'll start off with 1 and 60. Okay, that adds up to be 61. 60 divided by 2 is 30. 2 plus 30 is 32, so that's not it. 60 divided by, 3 is 20. 3 plus 20 is 23. 60 divided by 4 is 15. It's close, but 4 plus 15 is 19. And 60 divided by 5 is 12. There we go. 5 plus 12 is 17. So it's 5 and 12. Now, when we get to number 3, we do have to remember there's 2 ways to multiply and get a positive value. We can do positive times a positive. We could also do negative times a negative. So for this one, start off 1 times 20 is 20. Well, 1 plus 20 is positive 21. I want negative 21, so I'm going to have to do negative times a negative on this one. And I find it right away. Last but not least, number 4. If it multiplies to be a negative, that means I have one negative sign. Okay, so negative 1 times 10, and I add. That adds up to be positive 9. Next number is 2. 10 divided by 2 is 5, so I'm going to go negative 2 times 5. That's negative 10. Negative 2 plus 5 is 2. Oh, snap. Mr. Alone put the wrong number here. Oh, snap. That one would not have had it. I apologize. That's supposed to be a 3. Okay. So that's what I intended is for this to be a 3, not a 2. There would not have been one if it would have been adds up to be 2. That was one I intended to be. So I apologize for number 4. Again, we'll continue working on that next week, all throughout the week, Monday to Thursday. But let's go ahead and go on to our lesson. Okay. Now, we are going to be learning about all the different types of exponential properties. So the first 2 that we need to talk about are just basic principles with 0 and negative exponents. Okay, so just to kind of help you understand these basic principles. So 2 to the 4th power, remember that's 2 times 2 times 2 times 2. 4 2's multiplied together, that's 16. 2 to the 3rd power is 8. 2 squared is 4. 2 to the 1st power is 2. Okay, so the first one we're going to look at is what does a 0 exponent do? Well, if we look at the pattern that starts here, you go from as these exponents go down, 4, 3, 2, 1, okay, our numbers are also happen to be going down. To get from 16 to 8, we are dividing by 2. To get from 8 to 4, we are dividing by 2. To get from 4 to 2, we are dividing by 2. So if I go down one more exponent, 2 to the 0 power, I should be dividing by 2. And 2 to the 0 power, then 2 divided by 2 is 1. Okay, so here's the first rule. Anything raised to the power of 0 equals 1. So it doesn't matter what this base number is. These are 2's. Okay? It doesn't matter what the base number is. Okay? If I raise it to the 0 power, the answer is going to be 1. Okay? The next part is, what do negative exponents do? So let's keep going. Let's keep going in reverse. 2 to the negative 1 power, 2 to the negative 2 power. Well, if we still follow this pattern, dividing by 2. Well, 1 divided by 2 is 1/2. Okay? 2 to the negative 2 power. Well, I divide by 2. Well, that's going to be a fraction 1/4. Well, what I want you to notice here is the connection between 2 to the first and 2 to the negative first. Okay? Notice where the 2 is. Okay? All it does, 2 to the negative 1, is it moves this 2 to the denominator. Same thing, look at 2 to the second, which is 4. 2 to the negative second is 1/4. Okay? So what does the negative exponent do? Basically flips it, other part of the fraction. Okay? So, we could describe it as this. A to the negative 2 power just means I go 1/a squared. That's just telling me to move my a squared to the bottom. Okay? Now, we will not see this scenario very often, but if you did have 1/a to the negative 2, it's already on the bottom. That would move it to the top. Okay? But this is the one we're going to see primarily. Okay, now, you'll see those two properties get used as we are doing the problems, okay? So, let's go ahead and first start with the multiplication property of exponents. Okay, so multiplication property of exponents. Essentially, we have two values being multiplied together. Now, one of the big things is they do have to be the same base for these to occur. Okay, now if we think about it, a to the third, that means there's 3 a's, so a times a times a. A to the fourth, if I expand it, that is 1, 2, 3, 4. Well, how many a's do I have total here? 1, 2, 3, 4, 5, 6, 7. Okay. Well, there's a shortcut. We do not have to expand it every time. Okay? Now, again, it has to be the same bases. They both have to be base a's. Okay. But the rule is this. If I multiply same bases, I can run a shortcut. I can add the exponents. Okay, so essentially, if I had these two, I do not need to expand it. All I would have to do is add the exponents. 3 plus 4 is 7. Okay. If I showed another one, x to the fourth times x to the negative 1. Well, I don't have to expand anything. All I have to do is add the exponents. 4 plus negative 1 is positive 3. So I would say it's x to the third. Okay. Now, we're going to do two examples. These two examples are ones that you will see potentially on the quiz when we take it on Monday. Okay, so let's go ahead and look here at number 1. Now, the instructions, notice they say simplify, and then your answer should contain only positive exponents. So what that means is at the end, if you end up with a 0 exponent or a negative exponent, you do need to fix it. Okay, so you'll see that I do that as we go through these problems. Okay. So we have 2ab to the fourth times 4a to the fourth b squared. Now, it is important that we don't misapply our rules, okay? Numbers are numbers. So like 2 and 4, those are just numbers being multiplied together, okay? 2 times 4 is 8. It's 8, okay? That's not going to change. 8. Now, the a's are same bases. Those are being multiplied together. Now, it's a very common mistake with this first one, okay? With this first one, we have to remember that that is a to the first, okay? If they don't put the exponent there, it's a to the first. So I have a to the first times a to the fourth. Well, 1 plus 4 is 5. With our b's, we have b to the fourth times b squared. Well, got to add those. 4 plus 2 is 6. My problem has no negative or zero exponents, so I am done. Okay. Let's look at number 2 here. We have 4a b to the negative 3 times 4a to the negative 2 b to the third. Now, one thing that's helpful is right away on this a right here, I'm going to go ahead and put its exponent of 1. That way I don't forget it later. Okay. And I'm going to do the same type of thing. I'm going to organize this. So I know my two numbers go together, 4 times 4. My a's go together, a to the first times a to the negative 2. And my b's go together, b to the negative 3 times b to the third. Okay, so 4 times 4 is 16. For the a's, 1 plus negative 2, that's negative 1. For the b's, negative 3 plus 3 is 0. Well, I have both a negative and a 0 exponent. I got to fix some things. Okay, so the 16 is perfectly fine where it's at. The a has a negative exponent, so that moves the a to the bottom of the fraction. B to the 0 power is 1, okay? So essentially, that's going to be gone, because 16 times 1 is just 16. So I have 16 on the top and a to the first on the bottom, and that would be my final answer. Okay. All right, let's look at our next property. I'm going to have to refresh this. Our next property is going to be the division property of exponents. Now, the division property of exponents looks something like this. We have a to the 7th divided by a to the 4th. Well, the long way, I would expand this and I would say, okay, that's 7 a's on the top. 1, 2, 3, 4, 5, 6, 7. I would expand this. That's a to the 4th. That means 4 a's multiplied on the bottom. And remember our rules for simplifying. If I have an a on top and bottom, those can cancel out. So all these cancel out, and that leaves me with 3a, so a to the 3rd on the top. Well, I don't need to do this step every time. Okay, I don't need to do that step every time. So there's a shortcut. Here's the shortcut. If I, let's go ahead and abbreviate here, divide same bases, again, it has to be same bases, I can subtract the exponents. And with subtraction, it is extremely important that you are writing down your subtraction problem, okay? Because this gets missed I would say the most out of all of them are these types. So you could have something like this, like x to the 8th over x to the 3rd. Well, I don't need to do all the expanding. I can subtract these. 8 minus 3. You always go top minus bottom. 8 minus 3 is 5, so I would be x to the 5th. Okay? Now, again, you need to be very careful, especially when dealing with negatives. Okay? So we're going to go through 2 problems again, 2 examples for this. Here's our first one. So we have 4u to the 4th, v to the 3rd, over 6u to the 3rd, v to the 4th. Now, again, it's important that we are separating our information. Okay? This part right here, the numbers are not exponents. Okay? They're not even same bases. That is just simply a fraction, 4 over 6. Okay? And the fraction 4 over 6 can be simplified. I can divide both the top and the bottom by 2. So that is going to become 2 over 3. Okay? And I made the little extra long fraction bar because I have other work to do. Now the u's. I have u to the 4th over u to the 3rd. Well, I'm doing a subtraction problem. That would be 4 minus 3. 4 minus 3 is 1. So I put it right there. Now, when you do divide, when you use a division property like this, you put the answer on the top. Okay? The v's. I have v to the 3rd divided by v to the 4th. Well, for the v's, 3 minus 4 is negative 1. I have one small issue here. Okay, this v has a negative 1, so I need to move the v's to the other part of the fraction. So my final answer would be 2u to the 1st over 3v to the 1st. And I would accept it with, this is how they would write in the book. If it's 1, they don't write the 1, but I would accept it with the 1s there. Okay, number two. Now, start off with the fraction. 12 over 8. Well, I can simplify that fraction. I can divide the top and bottom by 4. And that's going to leave me with 3 over 2. Again, I left space for the other information. My x's. X to the 1st divided by x to the 1st. Well, that'd be 1 minus 1. That would be 0. Now, since it's 0, I don't need that. So I actually can just cross it off. The x's are gone. They've disappeared. The y's, I have y to the 4th divided by y to the negative 1. Now, here's where you got to be really careful. This is 4 minus a negative 1. Minus a negative turns into plus. That's going to be y to the 5th. So my final answer, when I clean this up, I would have 3 y to the 5th over 2. Okay, and that's the division property. Last but not least, we have the power property. Now, the power property is when you take an exponent and you raise it to another exponent. So you have something like this. A to the 4th raised to the 3rd. Well, what this means is I have a to the 4th 3 times multiplied together. Okay, a to the 4th times a to the 4th times a to the 4th. Now we have our addition rule, which means I can go ahead and add all those together because they're all base a's. 4 plus 4 plus 4 would be 12. But I can do a shorter version. Okay, so here's a rule. If I raise a power to a power, I can multiply the exponents. Okay, so essentially all we're doing here is going, okay, that'd be 4 times 3, that's 12. Okay, so if I did another example, I could have x to the 10th raised to the 5th. Well, I don't have to go through all that work. I just know this is power raised to another power. I'm just going 10 times 5. So 10 times 5 is 50. Okay, so I have x to the 50th power. And let's go ahead and look at a couple of examples of this. Okay, so let's go ahead. Sorry, there's 3 examples of this one. Okay, so number 1, we have 4 x squared y to the 4th in parentheses raised to the 4th power. Now, here's the thing. This 4 does have an exponent on it. We never write it, but it does have an exponent. It's an exponent of 1. Oops. And I have the power property here. Okay, so this exponent is being multiplied to all of the exponents that are inside that parenthesis. So for this particular one, for the 4, 1 times 4 is 4. So I'd have 4 to the 4th power. For the x, 2 times 4 is 8. And for the y, 4 times 4 is 16. The only thing I have to make sure I take care of is 4 to the 4th power. So it'll be 4, 16, 64. I believe it's 256. Yep. So this would be 256 x to the 8th, y to the 16th. No 0 or negative exponents to deal with, so I am done. For number 2, okay, all of these are raised to the 4th power. Okay, so remember this 3 has a 1, and this 4 is what we are multiplying to all 3 of those. Okay, so for the 3, 1 times 4 is 4. For the u, 2 times 4 is 8. And for the v, 4 times 4 is 16. And now I'm going to take care of 3 to the 4th power. Remember, that's 3 times 3 times 3 times 3. That would be 81. U to the 8th, v to the 16th. No 0 or negative exponents to deal with, so I am done. Okay, number 3 is unique, okay? Because there was a rule we learned in the very beginning. Anything raised to the 0 power equals, look back at your notes, anything raised to 0 power equals 1. So I don't have to do a bunch of work because I know that this whole thing is raised to the 0 power. So I know the answer is 1. Okay, now if I did the work, okay, I would literally have, for the 2, 1 times 0 is 0, so I have 2 to the 0. For the u, 3 times 0 is 0, so I have u to the 0. For the v, 2 times 0 is 0, so I have u to the 0. Well, remember, anything raised to 0 power is 1. So I'd have 1 times 1 times 1. That's still going to get me here, but I can do it right away. Okay, that's the power property. Okay, what you have now is you are going to get on Alex, and you are going to do your homework on there. The Alex assignment is sitting there for you. Make sure that if you are someone who still does not have or you forgot your Alex information, make sure that you are sending me an email, and I will get that to you right after I get the email. Okay. You'll see the assignment when you go to assignments there. It says property of exponents, day 1 homework. Okay. Make sure you get that done. You are allowed to retry the problems immediately. Okay, so make sure that if you're getting them wrong and you're not sure why, shoot me a screenshot of what you have, and I can help you out because it could possibly just be the way that you were typing it in. All right, have a wonderful day, and we'll see you.